Good morning. Myself, Dr. Irfan. I am handling the course Electric Vehicles. Today's topic of my session is EV powertrain and key components. As I already mentioned in the last class, the significance of electric vehicles. Electric vehicles play a major role in transforming the environment from pollution to pollution free. Because almost 40% of the pollution created is due to the transportation sector. So obviously, if we replace the conventional vehicles, then electric vehicles may reduce the pollution and make our environment pollution free. Let me start with the technical content. Classification of electric vehicles. Basically, electric vehicles can be classified into vehicles can be classified into three types. One is conventional vehicles, that is internal combustion engine vehicles. Second one is hybrid electric vehicles, and third one is all electric vehicles. In hybrid electric vehicles, we can have again three types. One is mild hybrid, full hybrid, and plug-in hybrid. And all electric vehicle, we are having two types: battery electric vehicles and fuel cell electric vehicles. Yeah, let me start with first one, battery electric vehicles. Battery electric vehicle is also called as all electric vehicle because this electric vehicle is powered by the battery. So obviously we are not having any other source of power, only batteries we are using. So we can also call it as all electric vehicles. No internal combustion engine will be there. This is the basic configuration. Here I have shown the power is given to the motor from the battery, and through the motor axles will be connected to the wheels where the mechanical power will be transferred to the wheels and the vehicle will be moving. These are the variety of companies are the models which they are using this battery type of electric vehicles. Tesla Model 3, Tesla X, Toyota RAV, BMW and Kia Soul. The second one is hybrid electric vehicles. Again, in hybrid electric, we are having micro, mild, full, and plug-in. As I already mentioned, hybrid is the combination of two or more sources of energy. In addition to batteries, if you are using internal combustion engine, or flywheel, or ultracapacitors, or fuel cells, then those type of vehicles are called as hybrid electric vehicles. Micro and mild represents only some part of the vehicle power will be driven by the electricity. Major portion will be driven by the ICE, internal combustion engine based mechanism. Full hybrid and plug-in hybrid, here the major contribution will be from the batteries and only minor portion will be contributed by the ICE engine. The difference between this hybrid electric vehicle and plug-in hybrid electric vehicle is, normally in hybrid electric vehicle we don't have any output port for charging the vehicle, for charging the battery of the vehicle. So whenever we are applying the brakes, the kinetic energy available in the wheels will be converted back to electrical energy and you are charging the battery. This is called as regenerative braking. Whereas no external source will be added for charging the battery of the vehicle. Such type of vehicles are called as full hybrid electric vehicles. Whereas if you want to charge the batteries using your wall outlet from the power supply grid, then obviously we have to use the plug-in hybrid electric vehicles. You can have a source from the outside to charge the battery through the charging port. Yeah, this is plug-in hybrid electric vehicle. We can see here the external electricity charging port is available here, through which we can also charge the battery using external power supply. On the other hand, we are also having the regenerative braking. Whenever you are applying the brakes from the wheels, it is coming to the motor, and this motor will be acting as a generator, and then this electrical power generated from the generator will be used to charge the battery. This is the regenerative braking. This is second type of hybrid electric vehicle. Third one is pure hybrid electric vehicle, where external port will not be there for charging the battery. Only through regenerative braking we are charging the battery. Other time we will be using the internal combustion engine. This is called as hybrid electric vehicles without any plug-in possibility. The fourth one is fuel cell electric vehicles, all electric vehicle it is also. because we are using only one source of power, that is fuel cell. Nowadays we are using hydrogen fuel cell, with the help of which easily you can charge your battery. Yeah. Coming to the next topic, that is electric propulsion system. Basically, in conventional vehicles, the mechanical power will be generated using your engine. Here, the same sort of propulsion will be generated using the electric power. Hence, we call them as electric propulsion unit. There are four different modules in the electric propulsion unit. Here you can see, first one is energy storage, which is very important because this is the basic source of power through which you are getting the power. And then the amount of power, whatever the variable power you want to the motor, that will be given through power electronic converter. For example, you want to control the speed of your vehicle. So obviously, to control the speed of the vehicle, you have to control the speed of your electric motor. How you will control the speed of your electric motor? By getting the variable voltage. So directly battery can't give the variable voltage. So obviously you have to use the power electronic converter, which will be converting the fixed voltage to variable voltage as per the requirement of the motor, and that input will be used by the motor to get the variable speed. This is how the mechanical power will be transmitted through the axles to the wheels. Electronic controller and electric controllers also there, which will be used especially for taking the decisions regarding the battery management system, regarding the speed control, and also other different aspects are there we will be discussing in the coming classes. Yeah, if you take one by one the components, electric motors, how you are going to choose the electric motors? The requirements of the electric motors for the electric vehicles are much more demanding than that for the industrial applications. The basic requirements are frequent start and stop, high rate of acceleration and deceleration, high torque capability, low torque and high speed cruising, high torque and high power density, wide speed range, high efficiency, wide constant power operating capability, and low acoustic noise and reasonable cost. These are the basic requirements we have to check while you are selecting the appropriate motor for your electric vehicle. The basic thing what the electric vehicle motor should do is it has to generate a power in terms of getting a wide range of speed, and also good voltage regulation it has to maintain, and also it has to be capable of being integrated with the engine, because engine is a mechanical part. Obviously we have to integrate the motor shaft with the engine, thereby our motor will be moving in the hybrid electric vehicles. Power electronic converters are used to get the appropriate voltage and frequency with respect to the variable speed of the motor, and that variable speed will be directly reflected as the variable speed of the vehicle. Not only speed but also torque. Electronic controller divided into three functional units. Sensors will be there, interface circuitry will be there, and the processor. Sensor is used to translate the measurable quantities such as current, voltage, temperature, speed and torque into the electric signals through interface circuitry. And the translated electric signals are conditioned to appropriate level being fed to the processor. Output signals are usually amplified via the interface circuitry to drive the power semiconductor devices. Yeah, the choice of electric propulsion system mainly depends upon several factors like driver's expectations, vehicle constraints, and type of the energy source. Driver expectations is nothing but it is a driving profile of the driver. How frequently he will be applying the brakes, how frequently he will be accelerating, what is the pattern of gear changing, and during the climbing how effective the driver is driving the vehicle. So all these constraints also means the driver's expectations play a major role while you're selecting the electric propulsion. Second one is vehicle constraints. So vehicle constraints include the mass, total overall weight of the vehicle, and also the total load capacity, payload capacity of the vehicle. It also very important factor while you are designing the electric vehicle. Third one is very important is energy storage device. Basically this is the storage, this is the energy source which will be delivering the power to the motor or the vehicle to drive. So whether you are using batteries or fuel cells, ultra capacitors, or any hybrid sources are there, this is also one of the major factor upon which you have to select the electric propulsion system. Yeah, this is your electric propulsion system basic block diagram. Here you can see the flow of power. This is the mechanical parts, brakes and accelerator are there. So brakes or accelerator directly, this is the interface through which you are giving the variable speed or the variable torque. And this is a vehicle controller which is taking the decisions and conveying the decisions to the power converter. And power converter will be giving the appropriate voltage and current to the motor to get the desired amount of speed. Next one is battery bank. Battery bank is also very important. Through battery bank, we are getting the power to the motor via power converter. And here energy management unit is there and charge controller. Here we can see through the charging station, your charge controller is nothing but charger. Through the charger, you are charging the battery. And when to charge the battery, the decision will be given by the energy management system. In our language, we generally call it as battery management system, BMS. This BMS acts a very important role. The purpose of BMS is not only to secure the vehicle, provide the safety, but also to control. So it is controlling the vehicle through a different decision making process. The mechanism will be taking the closed loop control system. It will be taking the desired amount of speed requirements and torque requirements for the from the vehicle, and then it is giving to the motor through power electronic converter. One more additional thing is auxiliary system for steering purpose, lightning, or for AC, or for your seat adjustment, windows, everything we also requires electrical power. So direct this battery bank can be used, or one more battery we can use for the auxiliary system. Here three things I have shown. One is electrical power flow, second one is mechanical flow, and third one is control. The arrow marks with the bold one, they are representing the electrical links, and the arrow marks without any bold, they are representing the control signals, and without arrow marks, whatever the bold lines I have kept here, they are representing the mechanical power links. See here, from the charger, charging station to the charger, charger to the battery, battery to the power electronic converter, power electronic converter to the motor. This is how the electrical power supply is flowing from the charging station to the motor, and for an auxiliary system also. And these are the control signals. How much amount of power the battery has to give, how much amount of voltage and current the power converter has to give. All these are control signals. Through these instructions and commands, the power electronic converters will be operated. And this is from motor to the mechanical transmission, and mechanical transmission via axles to the wheels of the vehicle. This is the mechanical power transmission. So mechanical links are there. This is the overall powertrain configuration. Powertrain is nothing but the flow of power from the battery to the wheels. Battery to the wheels. This is called as powertrain. We are having different types of let me go with the schematic layout of the battery powered electric vehicle. Yeah, this picture is representing the basic component structure configuration or the layout of the electric vehicle. Yes, here we can see from the battery charger you are getting to the battery, and from battery it is going to the bidirectional converter, through bidirectional converter inverter is nothing but power electronic converter, and from there to electric motor, and the electric motor is directly connected to the wheels. Let me start with one of the each component. Battery charger already we know very well. From the AC wall outlet, we have to convert that AC to DC using rectifier, and as per the requirement of battery, we need to step up or step down the rectifier voltage DC to using DC to DC converter, and we have to charge the battery. After charging the battery, this battery voltage we can't directly give to the electric motor. For example, in this picture, the electric motor whatever I have shown is AC motor. Let us take an induction motor. Induction motor requires AC voltage and frequency, right? So this battery can't deliver the AC voltage, so it has to convert into AC using inverter. So this inverter will be converting the voltage of the battery to AC, and that AC voltage will be given to the electric motor. This bidirectional converter it is used to step up or step down the voltage of the battery as per the requirement of the inverter. Whatever the inverter DC bus voltage requirement is there, that input of the inverter will be getting from the bidirectional converter, and to the bidirectional converter the input is coming from the high voltage battery. Okay. So the purpose of inverter, why we are using inverter is, inverter will be converting DC to AC, not only fixed AC but also variable in terms of magnitude and frequency. That's the reason we are using this inverter to convert fixed voltage, to convert from DC voltage to AC, and that AC also variable speed with variable voltage with variable frequency. This variable voltage and variable frequency will give the variable speed of the motor, which will be directly driving the wheels of the vehicle. In addition to that, for auxiliary loads, if you are using the same battery, one more DC-DC converter we have to use, because the auxiliary loads will be requiring some different voltage levels. To get those voltage levels, we have to use a DC-DC converter, which we can call it as your DC-DC chopper. Step up or step down we can use as per the requirement. This is a schematic layout of your electric vehicle. There are two modes of operation, as I already mentioned. First one is for charging the battery. Second one is for discharging the battery. Let me start with first model. It is called as battery mode, where your battery will be discharging. Means power flow will be from battery to the wheels. Battery to the wheels. Battery, next DC-DC converter. As I said, DC-DC converter will be stepping up or stepping down the DC voltage as per the requirement of the inverter. So whenever it is getting the input, the inverter will be converting DC to AC and it is giving to the motor, and the motor will be using that variable voltage and variable frequency to get the variable speed, and this speed will be transmitted to the wheels. On the other hand, if you are having auxiliary loads, DC auxiliary loads and also AC auxiliary loads. For DC auxiliary loads, from the battery you can use here using some DC-DC converters, and from AC auxiliary loads directly from the inverter you can use that AC power and you can operate your auxiliary loads. This is first mode of operation, where your power flow will be from battery to the wheels. The second flow is from wheels to the battery, reverse. It is called as regenerative braking mode, where the power flow will be fed back from the wheels to the battery for charging the battery. So whenever you are applying the brakes, the kinetic energy available in the wheels, that kinetic energy is nothing but mechanical energy, will be converted to electrical energy. So the same motor will be acting as generator, and this mechanical energy will be converted to electrical energy using the generator, and that electrical energy will be AC. Obviously that AC will be converted to DC using this inverter. Now this inverter will be acting as rectifier, because it is converting DC to AC, and then that DC, it will be step up or step down as per the requirement of the battery using the DC-DC converter, and then that voltage will be used to charge the battery. So this is in the reverse direction. The power flow is happening in the reverse direction, from wheels to the motor, motor to the rectifier, rectifier to the DC-DC converter, and then to the battery. So bidirectional converters we need to use. Means the switches used in the power electronic converters should allow the flow of power in both the directions. Those are called as bidirectional converters. Through bidirectional converters this is possible. These are the two different types of power flow happening in electric vehicles. One from the battery to the wheels, which a normal power flow, where your battery will be delivering the power. Second one, reverse, from wheels to the battery. Here power will be fed back to the battery and battery will be charging. This is called as regenerative braking. There are 6 different types of possible configurations. Configurations in the sense the placement of the key components, how we are placing the key components, how you are forming the train, power train, the flow of power from the battery to the wheels. Let me start with the basic one. Here I have taken the energy storage device. Anything you can take, ultra capacitors or what we call the batteries or fuel cell. From there the power electronic converter, there to the electric motor. From electric motor we are giving to the clutch, and through clutch to the gearbox, and from gearbox to the differential. From differential it is connected to the wheels through axles. The purpose of clutch is to connect and disconnect the motor with the gearbox. Why? Because gearbox is actually used manually to change the speed of the vehicle. Whenever you are shifting your gear from 1 to 2, 2 to 3, obviously your speed will be changing. The range of speed where you can operate your vehicle will be varying. This is called as gearbox. So in between the gearbox and the electric motor you will be having clutch. This clutch will be just acting as a mediator to connect and disconnect the gearbox with the electric motor. And gearbox will be used to vary the speed of the motor, and this speed will be given to the differential. At the differential, this speed will be equally divided to the two wheels, through the axles. This is the basic powertrain configuration what everybody knows. The second one is about the automatic vehicles. We won't have any variable gearbox. We don't have any clutch. Directly we will be having fixed gear system. With the help of fixed gear system, we are connecting the motor, and motor speed will be directly given to the differential through which it is given to the wheels. So gearbox will be of fixed type. Means gear 1 to gear 2, gear 3 will not be there. Only forward gear will be there, reverse gear will be there to move in the forward direction or to move in the backward direction. In between you will be having neutral gear. That's it. We don't have any specific manual gear system where we will be varying the speed. Everything will happen automatically. The third one also is automatic type vehicle, but the placement of the components is little different. Here we are using electric motor directly at the shaft of the wheels. Differential, fixed gearing and motors are not placed in the middle. Directly we are placing between the wheels. Through this, the transmission losses will be reduced and efficiency can be increased. Not only a single motor, two motors also we can use. This is fourth configuration. If we are using two motors separately for two different wheels, then obviously we want two different power electronic converters, because the electric motor speed will be controlled using the power electronic converter. So two power electronic converters we are connecting, and through the fixed gear system we are connecting to the wheels. This is fourth type of EV powertrain configuration. And the fifth one is very important. Directly fixed gear system will be mounted in the wheel itself. No need of any shaft and axles. Directly fixed gear system with electric motor will be mounted in the wheel itself, where much more transmission losses can be reduced, and also space occupied by the motor will also be reduced. This is having two different motors mounted in the wheel itself with fixed gear system. Next one is without any gear system, directly we can mount your electric motor itself in the wheel. This is called as in-wheel drive. Here each electric motor is having its own power electronic converter to operate the motor with variable speed. These are the 6 variety of configurations of powertrains, electric powertrains. The different companies and different manufacturing models are using different types of powertrain configurations. Every powertrain configuration has its own advantages and disadvantages with respect to the specific applications. The manufacturing companies are using these different configurations. This is in-wheel drive. You can see here in the wheel itself the motor is mounted, wheel itself, and over the motor you will be having the stator, rotor, power electronic converter and also the brake disc. Everything is very compact in size and also very precisely they are connected, and the whole setup is mounted in the wheel itself without wasting any space. and also there is no transmission, mechanical transmission between the motor and the wheels. Because the direct motor is connected in the wheel, obviously the speed of the vehicle will be equal to the speed of the motor without any transmission losses. So efficiency will be increased. This is in-wheel drive. The seventh configuration, which is nowadays very becoming predominant in the market, is all-wheel drive. All-wheel drive is not a general model, it is a specific application-oriented model. It is used especially where you want a better traction in the slippery conditions, where your road is very ghat road or very curvature road, you are climbing your vehicle, okay, or your sports cars are there, specific applications are there where you want your wheels to be operated with different angular motions, angular directions. So for such type of cars, we are using four motors in four wheels, or at least two motors will be there. One will be connected for the front wheels, another will be connected to the rear wheels. This type of motors are very much convenient to steer while you are parking in a very congested area, because every wheel can be operated individually with respect to its angular position. So Tesla Model S AWD, this is all-wheel drive. This is what available in the market. This is about all-wheel drive, seventh type of powertrain configuration. In all-wheel drive, we are having some hybrid models also. Like in addition to battery, we can also have one battery. We can also have two batteries, or one battery and one fuel cell. Okay, or else one fuel cell and one reformer, or one battery and one capacitor, or one battery and one flywheel. So extra amount of power flows, extra amount of energy sources also required, because obviously two motors we are using, so power demand will be more. Four motors we are using, so obviously power requirements will be doubled. So to get the double amount of power requirement, single battery is not sufficient. So we require two or three sources of power through which you can drive the motors, available motors. For that reason, we are using multiple type of power sources to drive the vehicle. Yeah, this is the basic structural view of the electric vehicles representing the key components. Here you can see this red color motor is there. This is your traction motor, and this blue color is represented as power electronic converter, and the second one represented as DC-DC converter. And initially at front we are using some a thermal system for cooling of the vehicle, because whenever you are using power electronic converters with power semiconductor switches, obviously huge amount of power handling capable switches are there, so they will be delivering the heat, huge amount of heat will be releasing. So to overcome the device from the runaway, thermal runaway, we have to use some thermal cooling system. Here one more battery we are using for auxiliary power supply of the secondary loads. This is your onboard charger. Onboard charger is nothing but the charging, the conversion of AC to DC will be there inside the vehicle itself. Directly you can connect from the wall outlet. That AC will be converted to DC using this onboard charger, and then that DC will be used to charge the battery. Transmission is represented for the mechanical purpose. Charging port is there here, and here this is the traction battery. Yellow color is there. No, this is whole space at the center of the vehicle will be used to place the battery backup. This is representing the schematic layout of the electric vehicle. Let us start with the key components. First and foremost important component in the electric vehicle is motor. There are variety of motors in the market. I have classified the motors into two varieties. One is commutator based motors and another one is commutator less motors. If we take the commutator based motors, generally we can call it as DC motors and AC motors. These DC motors again classified into self-excited motors and separately excited motors. In self-excited we are having series motors and shunt motors, and separately excited we are having field excited and permanent magnet motors. And in AC motors we are having variety of motors like induction motors, synchronous motors, permanent magnet brushless motors, switch reluctance motors, and also hybrid type of motors are there. Nowadays, BLDC motors also coming into picture. BLDC motors, switch reluctance motors, these are very predominantly used motors in the electric vehicles. The basic advantage of this AC motors is we are not using any commutator or the brushes. Commutators and brushes what we are using in the DC motors, they require maintenance. The continuous sparks whatever coming, they will be reducing the lifespan of the motor. Wear and tear happens, because of which the lifespan of the motor will be decreased because of the commutator and brushes. So without any commutators and brushes, we are using these commutator less motors. They are induction motors, synchronous motors, permanent magnet motors, switch reluctance motors, and also hybrid type of motors are there. Okay, my dear students, in the next class we will be continuing in detail about each of these motors, how we are operating the motors, and how we are controlling the speed of the motors, and also how we are controlling the speed of the motors in a very detailed sessions will be taken by me in the next coming classes. Next important key component in the electric vehicles is power electronic converters. We are having basically four types of power electronic converters what we use in our electric vehicles. First one is AC to DC converters, we also call them as rectifiers. Next one is DC to DC converters, we call them as choppers, and DC to AC converters, we call them as inverters, and also AC to AC voltage regulators are there. The basic purpose of rectifier is to charge the vehicle, to charge the battery. Whenever you are using the wall outlet AC power and charging the battery, that AC should be converted to DC using the rectifier. So rectifiers are used as chargers. DC to DC, as I mentioned, these DC to DC converters will be stepping up or stepping down the DC voltage as per the requirement of the battery and also as per the requirement of the DC motor. DC to AC inverters, they will be converting to DC power of battery to the AC. For AC motors especially, to get the variable speed, we are using these inverters with variable voltage and variable frequency. AC to AC motors also will be used to get the variable AC and variable frequency to get the variable speed of the motor. Third important component is about the energy storage device. Basically, we are having electrical energy storage, electrochemical energy storage, mechanical energy storage, and hybrid energy storage systems. Supercapacitors and also superconducting magnetic energy storage systems comes under electrical. Electromechanical are batteries and fuel cell. Mechanical are flywheel, pumped hydro, compressed air, liquid air. And hybrid is battery supercapacitor, or battery, or battery fuel cell, or battery super conducting magnetic energy storage system. These are the different types of energy storage systems. Each of them we will be discussing in detail in the coming classes. Battery management system is also one of the important component, vital component we are using in the electric vehicles. The basic objective of battery management system is to provide the safety during the operation and also improve the efficiency of the vehicle in terms of speed, in terms of distance, range, and also in terms of your speed and torque, getting the variable speed and variable torque. Battery management system is an electronic system which we are using to get the safe operation and also to get the safe operation and also to improve the efficiency. Yeah, dear students, I will close the session here. In the next class, I will be explaining about in detail about each of these components. I will go with the motors and then power electronic converters and then with the energy storage systems. Thank you very much.